Okay, we're back to geometric sequence. We're going to do a couple problems on exponential growth and decay. And these are in your book on page 23. So here's number 15. A bacterial population starts at 100,000 and increases by 15% per day. What is the common ratio? Well, it's increasing by 15%. To turn that into a decimal, don't forget about the original 100%. So really what we're talking about is 115%. So the decimal equivalent of 115% is 1.15. And that is our common ratio. When this common ratio is greater than 1, it means that the population is undergoing exponential growth. So let's have a look at the geometric general term here. So we're going for 7 days. So we want the 7th term. And we've got to take A, the first term. That's right here, 100,000. And then we've got to multiply it by the common ratio, that's 1.15, and then you can see here the power that we want to raise it to is n minus 1, so we want to raise it to the 7 minus 1 power. Well, that's just 100,000 times 1.15 to the 6th power. All right, let's go to the calculator. We've got 100,000. Oh, that's too many. 100,000 times 1.15 to the power of 6, close, and we've got 231,306. That's if they increase by 15% per day for 7 days. That's how many you would have, 231,000. Now, number 16. The population of bees in a hive is 60,000. The hive is infected by a mite, which reduces the population by 20% per week. What is the common ratio? Well, if it starts out at 100% of its population and it loses 20%, then that means it's left with 80%. So as a decimal, we call that 0.8. So our common ratio in this case is 0.8. Now we're going to plug that into the geometric general term. Now when this common ratio is less than 1, that's what we call exponential decay, right? Because that 60,000 is reducing. In problem 15, we had exponential growth because our common ratio is greater than 1. And in this one, we've got exponential decay because our common ratio is less than 1. Let's see what happens to the bees. So week 5, so we want the 5th term. And we need our starting amount, 60,000, times our common ratio, which is 0.8, to the n minus 1. Let's just call that 5 minus 1, 4. And we go to the calculator. So we've got 60,000 times 0.8 to the power of 4. And you can see it went down quite a bit. The bees in the hive are down to 24,576 of them left. All right, thanks for watching, everyone. See you next time.